This video is about polar coordinates. This is AP Precalculus topic 3.13. If you appreciate the content, please give it a like. Number 1. Plot and label the following polar coordinates on the polar coordinate grid above. Somebody recently commented on one of my videos that my explanations were not detailed enough. This hurt my feelings. Listen. This is the 5th video I've made on this particular topic. So guess what? I'm not going to go into as much detail as I did in the first videos where I introduced the topic. We are going to move things right along. If you need that extra detail, please make sure you go back and watch the first few videos. Anyways, polar coordinates are in the form r, theta, where r is the displacement from the origin. So for this example, the r value would be 2. And theta is the angle whose terminal side passes through the point. In this case, theta would be pi over 3. Having said that, there are multiple ways to name the same angle using polar coordinates. Point A has an r value of 2 and theta equal to 5 pi over 6. I've highlighted the 4 angles with a reference angle of pi over 6. We can think of pi as 6 pi over 6. So this angle in the second quadrant will be our 5 pi over 6. To plot point A, we will go 2 away from the origin because the r value is 2. And then we will rotate to 5 pi over 6. So point A is going to be right here. Point B has an r value equal to -3 and theta equal to 5 pi over 6. Though the r value is negative, at first I'm going to ignore the negative and move 3 away from the origin, and then rotate to 5 pi over 6. Now, because the r value is negative, we have to move in the opposite direction. So point B will be right here in the 4th quadrant instead of the 2nd quadrant. Point C has an r value of 2 and a theta equal to 3 pi over 2. Because the r value is 2, we will move 2 away from the origin, and then we will rotate to 3 pi over 2 radians, which is right here at the bottom. So this is the location of C. Point D has an r value of -3 and theta equal to 4 pi over 3. I've highlighted all the angles with a reference angle of pi over 3. We can think of pi as 3 pi over 3. So 4 pi over 3 will be right here in the 3rd quadrant. To graph point D, I'm going to ignore the negative for now and move 3 away from the origin. Then I will rotate to 4 pi over 3. However, because the r value is negative, we have to move in the opposite direction, landing here in the 1st quadrant. So point D is right here. Let's do the same thing for number 2. Point A has an r value of -2, and theta equals pi over 2. Ignoring the negative sign for now, we will move 2 away from the origin and rotate pi over 2 radians. However, because the r value is negative, we need to move to the opposite side. So point A will be right here on the negative y-axis instead of the positive y-axis. Point B has an r value of -3 and theta is -pi. The negative sign on the pi means that we will rotate in the clockwise direction. But let's start with r. we will ignore the negative sign for a moment and move 3 away from the origin. Now we will rotate that negative pi, which lands right here. However, since the r value is negative, we move in the opposite direction and land on the positive x-axis. So point B is right here. Point C has an r value of -2 and theta is equal to -5 pi over 4. Here are the 4 angles with a reference angle of pi over 4. Since theta is negative, we will rotate in the clockwise direction. We can think of pi as 4 pi over 4. Well, since we are moving in the negative direction, let's call it -4 pi over 4. Therefore, -5 pi over 4 will be pi over 4 beyond this, putting it into the second quadrant. -5 pi over 4 is right here. Ignoring the negative sign, we will move 2 away from the origin. Then we will rotate to -5 pi over 4. However, because the r value is negative, we need to move in the opposite direction, landing us right here in the fourth quadrant instead of the second quadrant. So point C is right here. For point D, r is equal to 3 and theta is equal to -5 pi over 3. Here are all the angles with a reference angle of pi over 3. Since theta is negative, we will rotate in the clockwise direction. We can think of pi as -3 pi over 3. And we can think of 2 pi as -6 pi over 3. So -5 pi over 3 will be right here. Pi over 3 before -6 pi over 3. Since the r value is 3, we begin by moving 3 from the origin. Next, we rotate to -5 pi over 3. And that's it. Point D is right here. Number 3. The location of a point in the plane is given by polar coordinates 2, pi over 4. Write 2 different representations for this point in polar coordinates. For instructional purposes, I'm going to write 3 different representations for the point with polar coordinates 2, pi over 4. In the end, I will have one point that is positive, positive. I will have one that is positive, negative, negative, positive, and negative, negative. Here are all the angles with a reference angle of pi over 4. The point 2, pi over 4 will be right here, assuming that we are looking at a circle with radius 2. I'm writing alternative names for this point, but whatever I write, it has to land on this same spot. Let's write a name for this point with a positive r value and a negative value of theta. Because the angle is negative, we will be rotating in a clockwise direction. We can think of -2 pi as -8 pi over 4. So this angle in the first quadrant can be thought of as -7 pi over 4. Pi over 4 before -8 pi over 4. So that gives us another name for this point, 2, -7 pi over 4. Next, let's come up with another name for this point with a negative r value and a positive value of theta. Because of the negative r value, the terminal side of theta needs to be in the opposite direction from the point. We can think of pi as 4 pi over 4. So this angle that is in the opposite direction from the point is 5 pi over 4. If we rotate to 5 pi over 4, the negative r value will take us in the opposite direction and we land at the target. So another name for this point is negative 2 comma 5 pi over 4. They only asked us for 2 different representations, so technically we are done. But just for fun, let's find another representation that has a negative r value and a negative value of theta. Because we are going to have a negative r value, theta needs to be in the opposite direction from the point. So it needs to be in the third quadrant. Because theta is going to be a negative angle, we will rotate in the clockwise direction. Therefore, we will think of pi as negative 4 pi over 4. So this angle in the third quadrant is negative 3 pi over 4. Pi over 4 before negative 4 pi over 4. So that gives us another name for this same point, negative 2 comma negative 3 pi over 4. Because if we rotate to negative 3 pi over 4, the negative r value will move us in the opposite direction, landing right on that target. Number 4. Let's write 2 or 3 different representations for the point with polar coordinates 3, pi. Let's assume that the circle drawn has a radius of 3. Pi radians means we will rotate a semicircle, landing right here. This is the target. We are given positive r and positive theta to begin with. Let's come up with 3 other representations. One that has positive comma negative, one that has negative comma positive, and one that has negative comma negative. Let's start by finding a name for this point that has a positive r value but a negative value for theta. Instead of rotating in the positive and counterclockwise direction, we can arrive at the same spot by simply rotating in the negative direction, clockwise. So instead of positive pi, this is negative pi. So another name for this same point is 3 comma negative pi. Now let's find another name for this point that begins with a negative r value. Because of the negative r value, theta needs to go in the opposite direction from the point. In the opposite direction from the point would be 0 radians, or I could have said 2 pi radians. Then the negative r value will move us in the opposite direction, landing on the target. So another name for this point is negative 3 comma 0. I challenge you to pause the video and find another name for this point that has a negative r value and a negative value for theta. Alright, I'm going to assume that you've done that. Because of the negative r value, the terminal side of theta needs to be in the opposite direction from the point. I cannot have a negative 0. That would be the same thing as what we have. So let's call this position negative 2 pi. Negative 2 pi. Schmeh. Negative 2 pi means we rotate a full circle in the clockwise direction, landing right here. However, because of the negative r value, we move in the opposite direction and hit the target. So another name for this point is negative 3 comma negative 2 pi. Number 5. Let's write 2 or 3 different representations for the point with the polar coordinates negative 5 comma 7 pi over 6. Let's start by plotting this point. Here are the 4 angles with a reference angle of pi over 6. We can think of pi as 6 pi over 6. Therefore, 7 pi over 6 will be right here in the third quadrant. However, assuming that the circle drawn has a radius of 5, the negative r value will move us in the opposite direction, landing us right here in the first quadrant. So this blue dot is the target. The given point has signs negative, comma, positive. Let's come up with 3 other names for the same point that has signs positive, comma, positive, positive, comma, negative, and negative, comma, negative. Let's write a representation for this point with a positive r value and a positive theta. So, positive r value. So we go out 5, and then we rotate positive pi over 6. So that's it, 5 comma pi over 6. Now let's write a representation for this point that has a positive r value and a negative value of theta. Because of the positive r value, we do not need to begin in the opposite quadrant. We will simply rotate directly to this point. However, we will do it in the negative clockwise direction. We can think of negative 2 pi as negative 12 pi over 6. Therefore, this angle right here is negative 11 pi over 6. That gives us another name for this point. 5 comma negative 11 pi over 6. I challenge you to pause the video and come up with another representation for this point with a negative r value and a negative value for theta. Let's see how you did. Because of the negative value of r, we need to begin in the opposite direction from the target. And because of the negative value of theta, we will be rotating in the negative and clockwise direction. We can think of pi as negative 6 pi over 6. So this angle that is across from the target is negative 5 pi over 6. And that's kind of it. Another name for this point is going to be negative 5 comma negative 5 pi over 6. Because if we rotate to the angle of negative 5 pi over 6, the fact that the r value is negative will move us in the opposite direction and we will land right on the target. Number 6. The location of a point in the plane is given by polar coordinates 3 comma 5 pi over 6. Which of the following gives another representation for this point in polar coordinates? Assuming that the circle shown has a radius of 3, let's graph the point 3 comma 5 pi over 6. We can think of pi as 6 pi over 6, so 5 pi over 6 will be right here in the second quadrant. This red dot is the target. Let's see if point A is going to hit this target. Because of the negative value of theta, we are rotating in the clockwise direction. We can think of pi as negative 6 pi over 6. Therefore, negative 5 pi over 6 is right here. However, because of the negative r value, we move in the opposite direction and land right here. Point A does not hit the target. How about point B? We will rotate in the clockwise direction to reach negative pi over 6. So negative pi over 6 is right here. However, because of the negative r value, we move in the opposite direction and hit the target. So the answer is B. Let us quickly observe why the other two answers are wrong. Negative 5 pi over 6 will be right here, and a positive r value leaves us right here. We did not hit the target, C is wrong. Positive 7 pi over 6 moves us in the counterclockwise direction. This is 6 pi over 6, so 7 pi over 6 is going to be right here. The positive r value leaves us right here. Not hitting the target, the answer is not D. Number 7. The location of a point in the plane is given by polar coordinates -1, pi. Which of the following gives another representation for this point in polar coordinates? Let's graph this point. This time we're going to have a unit circle with a radius of 1. If we rotate pi radians, we land right here. However, the negative r value moves us in the opposite direction, so we land right here. So this purple dot is the target. Let's see if point A hits the target. We rotate to pi radians, and because of the positive r value, we stay at pi radians. This is not the target. The answer is not A. What about B? We begin by rotating 2 pi radians. That's going to be all the way around and back to where we started from. However, because of the negative r value, we move in the opposite direction, landing right here. This is not the target. B is not the answer. How about option C? We begin at 0 radians. That's going to be right here. However, because of the negative r value, we have to move in the opposite direction, landing here. This is not the target, and C is not the answer. By the process of elimination, the answer must be D, but let's follow through and check it out. We begin at 0 radians, which is going to be right here. And because of the positive value of r, we stay right here, hitting the target. So that's why the answer is D. Number 8. The location of a point in the plane is given by polar coordinates -2, -2 pi over 3. Which of the following gives another representation for this point in polar coordinates? Here are all the angles with a reference angle of pi over 3. Let's plot this point. Because theta is negative, we rotate in the clockwise direction. -2 pi over 3 falls right here. However, if the circle shown has a radius of 2, the negative r value will take us in the opposite direction, landing right here in the first quadrant. So this green dot is the target. Let's see if point A hits the target. We can think of pi as 3 pi over 3. So 4 pi over 3 is right here. This does not hit the target. Because we have a positive r value, we will stay right here at 4 pi over 3. We will not go in the opposite direction. So A is not the answer. Similarly, 2 pi over 3 is right here. B is not the answer either because we have a positive r value leaving us right here in the second quadrant. We are not hitting the target, so B is not the answer. Pi over 3 is the reference angle itself, so we are starting right here at the target. And because the r value is positive, we stay at the target. We do not move in the opposite direction. So C hits the target and is the answer. Let's briefly observe why D is not the answer. 5 pi over 3 is going to be right here. And we have a positive r value, so we will stay right here, missing the target, and D is not the answer. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.